A determinant is a single number that we calculate from a square matrix. In this worked example, we will find the determinant of a 2 by 2 matrix, then the determinant of a 3 by 3 matrix, and then use these ideas to solve 3 equations in 3 unknowns. Before we calculate, it helps to picture what a determinant means. For a 2 by 2 matrix, it tells us how much a flat shape's area gets scaled, and for a 3 by 3 matrix, it tells us how much a solid shape's volume gets scaled. So watch how the same idea in 2 dimensions grows into 3 dimensions. For a 2 by 2 matrix, the determinant equals the top left entry times the bottom right entry minus the top right entry times the bottom left entry. Take the matrix with top row 3, 2, and bottom row 1, 4. The determinant equals 3 times 4 minus 2 times 1, which equals 12 minus 2, which equals 10. For a 3 by 3 matrix, we expand along the top row, multiplying each entry by the determinant of the smaller 2 by 2 matrix that remains after we delete its row and its column, and we alternate adding and subtracting these terms. Consider the matrix with top row 1, 1, 1, middle row 2, negative 1, 1, and bottom row 1, 2, negative 1. The first term comes from the top left entry, 1. We delete its row and column to get the 2 by 2 matrix with rows negative 1, 1, and 2, negative 1. That smaller determinant equals negative 1 times negative 1 minus 1 times 2, which equals 1 minus 2, which equals negative 1. So the first term equals 1 times negative 1, which equals negative 1. The second term comes from the top middle entry, 1. Since it's in the second position, we place a minus sign in front of it. We delete its row and column to get the 2 by 2 matrix with rows 2, 1, and 1, negative 1, and this smaller determinant equals 2 times negative 1 minus 1 times 1, which equals negative 2 minus 1, which equals negative 3. So the second term equals minus 1 times negative 3, which equals 3. The third term comes from the top right entry, 1. Since it's in the third position, we place a plus sign in front of it. We delete its row and column to get the 2 by 2 matrix with rows 2, negative 1, and 1, 2, and this smaller determinant equals 2 times 2 minus negative 1 times 1, which equals 4 plus 1, which equals 5. So the third term equals 1 times 5, which equals 5. Adding the 3 terms together, negative 1 plus 3 plus 5, gives a determinant of 7 for the 3 by 3 matrix. Now let's use this determinant to solve 3 equations in 3 unknowns. Our equations are x plus y plus z equals 6, 2x minus y plus z equals 3, and x plus 2y minus z equals 2. To solve using determinants, we use a method called Cramer's rule. For each unknown, we replace its column in the original matrix with the column of constants from the right-hand side, calculate the determinant of this new matrix, and divide it by the original determinant, which we already found to be 7. To find x, we replace the first column of the matrix with the constants 6, 3, 2, giving a new matrix with top row 6, 1, 1, middle row 3, negative 1, 1, and bottom row 2, 2, negative 1. Expanding this new determinant using the same cofactor method gives a value of 7, so x equals 7 divided by 7, which equals 1. To find y, we replace the second column of the matrix with the constant 6, 3, 2, giving a new matrix with top row 1, 6, 1, middle row 2, 3, 1, and bottom row 1, 2, negative 1. The first term is 1 times the determinant of 3, 1, 2, negative 1, which equals 3 times negative 1 minus 1 times 2 equals negative 3 minus 2 equals negative 5, so the first term equals negative 5. The second term is minus 6 times the determinant of 2, 1, 1, negative 1, which equals 2 times negative 1 minus 1 times 1 equals negative 2 minus 1 equals negative 3. So the second term equals minus 6 times negative 3, which equals 18. The third term is 1 times the determinant of 2, 3, 1, 2, which equals 2 times 2 minus 3 times 1 equals 4 minus 3 equals 1, so the third term equals 1. Adding these terms, negative 5 plus 18 plus 1 gives a determinant of 14, so y equals 14 divided by 7, which equals 2. To find z, we replace the third column of the matrix with the constant 6, 3, 2, giving a new matrix with top row 1, 1, 6, middle row 2, negative 1, 3, and bottom row 1, 2, 2. The first term is 1 times the determinant of negative 1, 3, 2, 2, which equals negative 1 times 2 minus 3 times 2 equals negative 2 minus 6 equals negative 8. So the first term equals negative 8. The second term is minus 1 times the determinant of 2, 3, 1, 2, which equals 2 times 2 minus 3 times 1 equals 4 minus 3 equals 1. So the second term equals minus 1. The third term is 6 times the determinant of 2, negative 1, 1, 2, which equals 2 times 2 minus negative 1 times 1 equals 4 plus 1 equals 5. So the third term equals 6 times 5, which equals 30. Adding these terms, negative 8 minus 1 plus 30 gives a determinant of 21. So z equals 21 divided by 7, which equals 3. Let's check by substituting x equals 1, y equals 2, and z equals 3 into all three original equations. First equation, x plus y plus z equals 1 plus 2 plus 3 equals 6, which matches the right-hand side. Second equation, 2x minus y plus z equals 2 times 1 minus 2 plus 3 equals 2 minus 2 plus 3 equals 3, which matches the right-hand side. Third equation, x plus 2y minus z equals 1 plus 2 times 2 minus 3 equals 1 plus 4 minus 3 equals 2, which matches the right-hand side. Since all three equations balance, we've confirmed that x equals 1, y equals 2, and z equals 3 is the correct solution, found using determinants.